All right, we're back here. What we're going to do in this tutorial is we're going to estimate cumulative abnormal returns in SAS. We did this in class using Excel, so we're going to try to do this in SAS. It's a little bit complicated, but I think it'll be worth your while for those of you who want to learn how to use SAS. There's going to be a whole bunch of new things that we talk about in SAS. For those of you who haven't looked at any of the tutorials, this line of code is the first thing I put on all of my SAS programs in this editor window. This is where I write my code. Again, basically what's happening here is I'm specifying my output screen. I want the maximum number of line spaces, LS. I want the maximum number of page spaces, which is 30,000 PS. And then I say no center because I want my output screen to be left justified instead of in the center. It gets really annoying to have to scroll over if everything is centered. So I'm left justifying my output screen. Okay, what I want to do now is I want to import the data. I'm going to use the SAS import wizard. Under File, Import Data. It says what kind of data do you want to import? It's a CSV file, so I'm going to, in the drop-down menu, click CSV. And then it asks me where the file is located. So I've saved the file on my computer. So wherever you've saved it, you're going to point the import wizard to that directory. And this is the data set here. You can see that it's a CSV file. It's called text docs. I'm going to double click that. And the import wizard points to the directory. And if I scroll over, you can see that there's my textdocs.csv data set. Okay. I'm going to click Next once I've located the file, and it's going to, by default, store this new data set. So it's going to import the CSV file, create a SAS data set that I can work with, and it's going to store it in a SAS library called work. Now, within this library called work, you can think of this library as just being another folder. In fact, look, it has a filing cabinet here for all of the libraries. I can name this whatever I want, right? I can name this cars. I can name this whatever I want. I'm going to name this data set T1 for technology stocks 1. And when I click Next, all I have to do is hit Finish. And Import Wizard is going to use a SAS procedure where it calls this CSV file. When I click Finish, it says work.t1 was successfully created. There's 462 observations and 6 variables. We can view this one of two ways. I can double click on libraries and go to my work folder there and double click on T1. There you go. And so this is what the data set looks like. I've obtained this data from the Center for Research on Security Prices, the CRISP data set. We've talked about that in class, hopefully. This first column is called the permanent number. This is just an identifier. CRISP gives every stock a perm number that stays with it, whether or not the stock is acquired by another one. You'll be more familiar with this ticker symbol. Of course, AAPL is Apple. Here's date 2011-09-01, so September 1st, 2011. So what I've done is I've grabbed 2 months of data, daily data, September and October of 2011, and Steve Jobs, of course, passed away on October, first part of October. October 5th, 2011 was the day that the market found out about it. This is just the SIC code, so I grabbed not only Apple, but I grabbed a whole bunch of competitors that had a similar SIC code. This here is the individual stock return for Apple. Okay, so on September 1st, 2011, Apple almost dropped an entire 1% there. And then this last column is the value-weighted market return. Okay. Let me explain something here. What we're going to do to estimate the cars, and this should be a review, is I'm going to estimate the following linear regression. I'm going to look at the returns for each individual stock I on day T, and I'm going to run a regression where I have some intercept plus some slope coefficient times the returns on the market in time period T, plus of course an error term. Okay, so my left hand side variable, my dependent variable, is an individual stock return. My right hand side variable is this market return, evaluated market return. And let me describe what that is. The evaluated market return is the average return for the universe of stocks that are listed on this CRISP data set, which contains the universe of publicly traded stocks that are traded on the New York Stock Exchange, the NASDAQ Exchange, or the American Exchange. Okay, so it's the average return from the universe of stocks, but the average return is weighted based on the market capitalization of those stocks. So the S&P 500 is another value-weighted market return, but it only consists of 500 stocks. Here, I have the universe of publicly traded stocks that are listed on those three main exchanges. I'm going to run this regression. And this error term, those who've taken econometrics, it's not necessary that you have to understand what I'm about to say. Those who've taken econometrics will remember that this error term is basically the portion of the returns, or the left-hand side variable, that is orthogonal, independent, or uncorrelated with the independent variable. So think of this. Watch. If I'm going to go ahead and estimate this regression, and I'm going to get estimated parameters for the intercept and an estimated parameter for the slope, and then this error term is going to be equal to, watch, I'm just going to do some algebra here, RIT minus my estimated parameter for the intercept from the linear regression minus the estimated parameter for the slope from the linear regression times the returns in the market in time period t. Okay, so this is the portion of individual stock returns that is independent of market returns. So think of it, something might happen to the entire market and a whole bunch of stocks might move because some market-wide information has come out. I want the portion of the individual stock return that is independent of the market movements. Okay, so my cumulative abnormal return is going to be equal to the sum of these residual returns, or this error term from the linear regression. Okay, so that's where we're heading. Let's do this. Let's just jump right in here. I've imported the data set. Let me close out of this. And what I want to do is I want to sort the data using a SAS procedure called sort. And I'm going to sort the data by ticker, so the ticker is alphabetical. The reason that I'm sorting the data is because I'm going to run another SAS procedure called procreg. This is going to give me a linear ordinary least squares regression. And I don't want to print the output yet. My model statement, just like I have here in the comments, is the return. Let me actually let me do something here before so I can print this. See what it is. Proc print data work.t1. I just want to print the first 20 observations. Okay, this will be easier because you can see. Oop, I didn't run that first line of code there, so it didn't left justify. So now you can see what's going to happen here. I'm going to run a regression. Here's my dependent variable. Here's my independent variable. And what I'm going to do is I'm going to estimate this thing by ticker. Okay. And then what's going to happen is I'm going to output a new SAS data set called T2, and I'm going to grab the residuals. Notice when I hit R equals, that R populates blue, which means SAS recognizes it as part of the procedures. It's going to estimate. It's going to estimate this guy right here. It's going to do the algebra for me. It's going to estimate the intercept, the slope, and then it's going to do the algebra for me. I'm going to call that abnormal return. Let me go ahead and print that new SAS data set once I run this, and you can see it's going to populate a new column. And that new column should be called abnormal return. And that abnormal return is going to be this formula here. So SAS was able to do that fairly quickly. Those who have taken econometrics will remember that these residuals, the mean of these residuals, or the expected value of these residuals, should be equal to 0. Let's just make sure that that's the case here. I'm going to run another SAS procedure called proc means on this SAS dataset data2, and the variable I want to run proc means on is this abnormal return. This thing should equal 0, the mean return, and look at that. So look, I got 18 zeros in front of that 2, so that's pretty close to 0. Okay, but notice I do have variation, right? The standard deviation is 0.28, and I have some variation. Okay, and what I want to see is, does that variation matter during the period surrounding Steve Jobs' death? Okay, so I got residuals here. I'm going to scroll up so you can see what's going to happen. What I want to do now is I want to sum up these abnormal returns to get my cumulative abnormal returns. This is going to be a little bit tricky. What I want to do is I want to proc sort data T2 by ticker and descending date. Let me print the data set after I've sorted this way to explain what this sort procedure is doing. Notice that my ticker symbol is sorted alphabetically, and then my date is descending now. The most recent date, October 31st, 2011, is the first date. The reason that I'm going to do this is, what I'm going to do is I'm going to lag the abnormal return down 1 day. And then I'm going to sum the abnormal return on the day that we're talking about plus the next days. Do you understand what I've done? Because I've sorted by descending date. Now I can create the cumulative abnormal return on day 0 and day +1. Okay? So watch what I'm going to do. I'm going to say data, create a new SAS data set called data 3. I'm going to set my old SAS data set called, T2. And I'm going to get a variable called abret1. And I'm going to use a SAS operator called lag1. Let me just show you what this looks like here. Notice that it created a new column here in this new SAS dataset T3, and it just lagged the day forward back 1. So then, to get car 01, I just take abnormal returns plus abnormal return 1. Right? And so this variable here is going to be equal to the sum of abnormal ret and abnormal ret1. Okay. Let me do this for another day here. We might want to look at the 3-day period surrounding Steve Jobs' death. Okay, hopefully this makes sense. I'm lagging this again. I'm lagging this again, and I'm creating another variable called car02, and that's going to be equal to the abnormal return, that residual return from the linear regression on day t. Glad I was looking at that more carefully. And then I'm going to add up the abnormal return the next day and 2 days from now. Okay. So notice abret2, it just lags this observation 2. And then car02 is going to be equal to this plus this plus this. Okay. So once I've estimated these cars, now I need to get an event window. All right. So I've created these car 02 for almost every day. Of course, not the last 2 days in the sample, but every day during this time period. So now what I want to do is I want to look specifically around the time, the day that the market found out that Steve Jobs had passed away. Let me create a new SAS data set called Apple, AAPL, set T3. Okay. Sorry, I was just checking something here. Create a new SAS data set Apple, set T3, and then I'm going to say if ticker does not equal, so caret equal says does not equal AAPL, then delete. Okay. And the reason that I'm doing this is I want to first examine the cars for Apple. Okay, look, that doesn't look like it did anything, but if I go up here to the log, I used to have 462 observations in my data set. When I get rid of all other stocks other than Apple, I only have 42 observations in my data set. Okay. So what I'm going to do here now is inside of this data set, I'm going to say if date does not equal 2011 10:05. This is October 5th, 2011 is the date that the market found out that Steve Jobs had passed away. I'm going to delete that. I'm sorry, I'm going to delete all other days that aren't equal to that date. Okay. And let's just look and see. So this is what happened. Notice that the abnormal, look at this. CAR 02 for Apple was negative 0.025881. In other words, over the 3-day period, Apple's stock price decreased almost 2.6% in excess of the entire market. So this, again, these are abnormal returns. These are residuals from that linear regression. So you can think of this as cumulative abnormal returns, or how much Apple's stock price decreased that was independent or uncorrelated with the market changes during that time period. Okay, so it looked like when Steve Jobs passed away, and this probably isn't surprising to you, when Steve Jobs passed away, Apple's stock price suffered. Okay, let's create another SAS data set called tech. These are all tech stocks. Set data set T3, and I'm going to say if ticker equals AAPL, then delete. And if date does not equal 2011 October 5th, then delete. So what's happening here is I'm creating a new SAS data set that's going to give me all of the tech stocks in the sample except Apple. So let's look and see what happened to Apple's competitors here. Okay. So I've got 10 of Apple's competitors. You'll recognize a few of those. There's HP, IBM. Okay. You'll recognize some of those ticker symbols. And what I want to do is I just want to take the mean return. Actually, look, you can see the CAR 02, these are positive and highly significant. Not necessarily for this one, but if I take the mean of these, if I take the mean of CAR 03, it's going to tell me that what happened to the average competitor of Apple during the 3-day period after Steve Jobs passed away. So I'm going to say proc means data tech variable CAR 02. Okay, that's the day T plus 1 and day T plus 2 for all of these 10 stocks that are Apple's competitors. And look, on average, in excess of the market, these 10 stocks increased about 1.5%. I can run another SAS procedure to determine whether or not that's profitable, or whether or not that's statistically significant. Okay, proc t-test will tell me whether or not this mean CAR 02 is significantly different than 0. Remember, I'm looking for a t-stat somewhere around 2. It's going to plot a bunch of stuff. The distribution of CAR 02. You can see that it's fairly normal distribution. And here you have it. For those 10 stocks, 1.5% average, and the t-stat is 1.77. That's pretty significant, right? The t-stat is not equal to 2, but that's getting up there, right? One of the reasons why it might not be statistically significant, even though we saw a whole bunch of positive CAR 02s for those competitors, is I just don't have a lot of observations. I only have 10 observations. If I pulled in more observations, maybe that t-stat would increase, and I could make some statistical inference that the competitors of Apple increased in stock price, again controlling for the market, increased in stock price surrounding the death of Steve Jobs.